the parameter that remains same for molecules of all gases at a given temperature is hashed. So let's check one by one. Kinetic energy of a molecule, the average kinetic energy, we can write it as 3 by 2 K into T, where K is Boltzmann constant, T is temperature. And it is kind of same for all the molecules, right? And the momentum we generally write it as m into v, and m is something which is going to change with respect to molecules of different gases. Say for oxygen will have different molecular mass, and nitrogen gas will have different molecular mass. So momentum, it cannot be same. As I said, mass is also not same because the values are going to differ, and speed is also not same because speed depends on both temperature as well as mass. Only parameter which is constant is kinetic energy. So we need to find the logical operation performed by this circuit. The input is A and one NOT gate is there, so it will become A bar. Here the input is B, it will become B bar. So A bar and B bar are the input of this NAND gate. The output will be written as A bar and B bar, the whole bar. And there is a De Morgan's theorem. There are two theorems. One is A and B whole bar can be written as A bar or B bar, and A or B whole bar can be written as A bar and B bar. So we will use the first one. It will become A double bar or B double bar. A double bar is A and B double bar is B. So the output we are getting as A or B, which means it is performing OR operation. In this question, we need to find the relation between acceleration and velocity. So an expression is given which relates time and distance. So let's write that expression and let's see what we can do to get this relation. So we have time which is equal to alpha x square. So time is equal to alpha x square plus beta x. So let's differentiate this time expression with respect to x. So which means both the side we have to differentiate with respect to x. Here we will get dt by dx, which is equal to 2 alpha x plus beta. So we know that velocity can be written as dx by dt and acceleration can be written as dv by dt, right? So this dt by dx can be written as 1 by velocity. So this is equal to 1 by velocity, which is 2 alpha x plus beta. Now we'll differentiate this particular expression with respect to time. So maybe this 1 by v I can write it as v power negative 1, which is equal to 2 alpha x plus beta. If I differentiate this one, then it will become negative 1 b power negative 2 dv by dt, which is equal to 2 alpha dx by dt. Since it is a constant, so it will become 0. Now we can rearrange this, like this dv by dt is acceleration. Here we have negative v square plus 2 alpha dx by dt is v. So acceleration will become negative 2 alpha v cube. So the relation between acceleration and velocity is a equal to negative 2 alpha v cube. First option is the correct answer. In this question, we need to find the angle of minimum deviation of the prism, that is delta min. We have to find angle of the prism is given, which is A. Refractive index is given, which is cot of A by 2. There is an expression which relates refractive index, angle of the prism and angle of minimum deviation, that is mu equal to sine of A plus delta min by 2 divided by sine of A by 2. So let me substitute the refractive index here. Refractive index is cot of A by 2 is equal to sine of A plus delta min by 2 divided by sine of a by 2. Let's expand this cos function. So, sorry, cot function. This cot function can be written as cos by sine. So it will become cos of a by 2 divided by sine of a by 2. So that is equal to sine of a plus delta min by 2 divided by sine of a by 2. So this sine a by 2, this sine a by 2 will get cancelled, and remaining thing will be the numerator of both the side, which is cos a by 2, that is equal to sine of a plus delta min by 2. Now we need to find the delta min, and we have two different functions. So it's better to write both of them into a single function using some trigonometry identity. So here I just want to convert everything into sine function. So we can use the identity that is sine of 90 degree minus theta, which is equal to cos theta. So I'm going to convert this cos function into a sine function. So sine of 90 degree minus a by 2 equal to sine of a plus delta min by 2. Since both the functions are same, both the side it is sine function, which means the argument should be same. So I can write 90 degree minus a by 2 equal to a plus delta min by 2. Now we can rearrange this. So this 2 I will multiply here. It will become 180 degree minus a equal to a plus delta min. So delta min will become 180 degree minus 2a. Yeah. So the angle of minimum deviation of the given prism is 180 degree minus 2a. Fourth option is the correct answer. In this question, there is an external magnetic field, and rigid wire is placed in this external magnetic field. We need to find the net force on this wire. So if we look at the shape of the wire, it is having two portions, or maybe three portions, two straight portion and one semicircular portion. Okay, and it is having current I, and magnetic field direction is given. There is a slight mistake in the actual question. The magnetic field is actually in the z direction. Like if you look at the figure and the axis is given, so based on that we can say that magnetic field is uh, coming out of the page, which means it is in the positive z direction. Okay, so we can say that net magnetic force is due to three uh, components or three parts. So two straight part, straight section, and one is semicircular section. So let's consider the straight section, maybe this one. So it is having current I, and let's consider the length is L. So here the force can be written as F equal to I L cross B. Okay. So how do we write this L vector? L vector we have to consider in the direction of current. So it will become I L, since based on this axis we can say it is in j cap direction. Okay, so it is in j cap direction, and cross product with B0 K cap. So this is for this particular section. Similarly, I can calculate for the other straight section. This one, let it be, okay, let this be F1 and that is F2. So here we will get I, L. In this case, it is negative J cap since current direction is downward, and B cross K cap. So if you look at both of them, like F1 and F2, their magnitudes are same, but the direction is opposite. When we add them, it is going to become 0. So this F1 plus F2 is going to become 0. So only we left with F3, that is the semicircular portion. So net force is equal to F3, that is due to semicircular portion. Okay. So if we have a semicircular portion, something like this, whose radius is R, and let's consider current as I. So it is placed in the external magnetic field. Now we want to find the force on it. We know how to calculate for a straight wire, right? But for the semicircular portion, we can consider this as straight wire and then find the force. How do we consider this as straight wire? We just know, we just need to know the starting point and the ending point and connect both of them and draw a straight line. That should be fine. So this is I and this is going to be F, and like this is our semicircular path. So irrespective of the shape of this one, if you consider the starting point and ending point, uh, and if you know the current, then the forces are going to be equal. Of course, I'm not going to do the derivation. This is a kind of result you can like consider, and we can find the force accordingly. So here the length is going to be twice of the radius, because like this side is going to be r and here one more r, so the length is going to be 2r, and current direction is in the x-axis direction, because like here you can see like this is what I'm talking about. So current is in this direction. So let's find the force F3. So I L vector B vector. So current I, instead of L it is 2R, and direction is x cap, which means I cap I have to write, and B0 K cap. So I cap cross K cap, it will be negative J cap. So I'll get 2I B R negative J cap. Yeah, fourth option is the correct answer. In this problem, wavelength of first member of Lyman series is given. Lyman series of hydrogen atom is given, that is lambda, and we need to find the wavelength of second member. So let's consider the energy levels of hydrogen atom. This is ground state, or first energy level, n equal to 1. This is second, this is third. So for Lyman series, always the transition ends at n equal to 1. So the electron usually jumps from higher energy level to the ground state. And due to that, some electromagnetic spectrum will be emitted, and that spectrum we call it as Lyman series. So the first member is because of the transition from n equal to 2 to n equal to 1. So this is first member. And second member is from the very next state, that is n equal to 3 to n equal to 1. This is the second. R into 1 by nf square minus 1 by ni square. This is for the hydrogen atom, where R is read by constant, nf is final energy level number, and ni is initial energy level number. Final orbital, initial orbital we can consider. Fine. So let's find the expression for lambda first. So 1 by lambda, which is equal to R into, this is for the first member. So final for Lyman series always it is 1, and initial for the first member it should start from n equal to 2. So it's going to be 2 squared. So if I simplify, I'll get 3r by 4. So if you take LCM and subtract, you will get 3r by 4. So from this, I can write r, which is equal to 4 by 3 lambda. So let it be as it is. Now we'll find the second member. Let's consider this is lambda dash, which is equal to r into 1 by nf squared. It is 1 only. And in this case, ni is 3. So 3 squared. And you will get 9, yeah, 8r by 9. So lambda dash we need to find. Let's rewrite this. 1 by lambda dash equal to 8 by 9 into R. We'll substitute the R from the previous finding. So 8 by 9 into 4 by 3 lambda. This becomes 32 by 27 lambda. Since we need lambda dash, which is equal to 27 lambda by 32. So first option is the correct answer. In this question, there are 4 masses which are kept in a corner of a square. So let's draw the square. Consider this is a square, and these are the 4 masses, and 4 are having equal mass. So let's consider the mass as m because it is given, and we'll assume the side length of the square is x. So that we need to find, and they have given the net force on one of the mass is to be 2 root 2 plus 1 by 32 into gm squared by l squared. So we know that gravitational force is attractive force. So if you have two masses, say for m1 and m2, if they are separated by a distance r, then the gravitational force between them given by g m1 m2 by r squared, and it is attractive force. So let's assume one of the masses. First we'll number it, like let this be 1, this is 2, 3 and 4. So we'll find the net force on the mass 1. So it will experience force due to the remaining masses. So this second mass will attract this in this way with the force F12. F12 means force on first mass due to the second one. Similarly, this one F13, and here this is F14. So now we'll write the magnitude of this forces. F12 magnitude, which is equal to G. We'll use this expression only, G m1 m2, since both are same. It's going to be gm squared by x squared, and this is equal to magnitude of F13. Okay, now if we'll write for F14 also, which is equal to gm squared by is going to be 2x squared. Here the distance between 1 and 4 is 2x. I'll explain how. We can use trigonometry. So this is a right angle triangle where both the sides are x. So the hypotenuse is going to be root 2x. So I'm using Pythagoras theorem. So if you use it, you will get this one. Okay. Now let's add this F12 and F13. So two forces are there. We are adding. There is a formula to add two forces or two vectors in general. If this is A vector, if this is B vector, if they are making angle theta, and so A vector plus B vector magnitude can be written as magnitude of A vector squared plus magnitude of B vector squared plus twice of magnitude of A magnitude of B cos theta. This is a basic thing in vector addition. So here, if we consider this F12 and F13, angle between them is 90 degree. So the third term in this addition will be 0. So we left with only first two terms. So let me write it. I'll put it as F123, which is the combination of F12 and F13, and I'm going to write magnitude of it. This is going to be magnitude of F12 square plus magnitude of F13 square. Since both of them are same, so I can write like this, twice of F12. So this is going to be equal to root 2 F12 magnitude. So this is F123. Okay, now if you look at the direction of this combination of two vectors, which is F12 and F13, it is going to act in this direction, which is along F14. So to find the net force, we can just add this F123 and F14. So F net, which is equal to F123 plus F14. So don't get confused, like somewhere I'm using this arrow mark, somewhere I'm not using. Here I'm trying to deal with magnitudes only. So that's why I'm not showing much interest on this sign. I'm explaining here. Fine. So now we'll just add both the magnitudes since the direction is same. I'll substitute here. This is root 2 f12 plus f14. So root 2 f12 is gm squared by x squared plus f14 is gm squared by here 2x squared. So if we look at the question, they have written something and multiplied with gm squared by l squared. So this gm squared by l squared, that one I just want to take it out. Gm squared by x squared, I take it out. Root 2 plus 1 by 2. So this will become gm squared by x squared into 2 root 2 plus 1 by 2. So this is the net force. And based on the question, this is equal to 2 root 2 plus 1 by 32. Let me check it. Yeah. By 32 into gm squared by l squared. Fine. So we can just cancel the numerator since both the sides are equal. Oh, sorry, it's not 32. Here it is 2 only. Yeah. So 32 L squared will become 2x squared. So x squared equal to 16 L squared. X equal to 4L. So length of the square is 4L. Here V and T graph is given for an ideal gas under isobaric process. So isobaric process means constant pressure. So here pressure is constant. And they stated ideal gas, which means we can use ideal gas equation, which is PV equal to nRT. So let's write P. P can be written as nRT by V. So I can say that P is directly proportional to T by V. So from this graph, how this T by V is related? Like, let's figure out. Only two things can be figured out from the graph. Either it can be a slope or area under the curve. So here, since division is coming, whenever division comes, you can think that we have to find something related to slope. Whenever two parameters are getting multiplied, you have to find the area. Since here it is division, so let it be angle theta 1. This is angle theta 2. So slope can be written as y by x. So in this case, even equal to, I can write. Slope is equal to, in this case, it is generally we'll write y by x. In this case, y axis is v and the x axis is t. So v by t. But what we need here, t by v, which means we have to invert it. So 1 by slope is equal to t by v. Okay, fine. So I can say that pressure is directly proportional to 1 by slope. So whatever process is having lesser slope will have more pressure. So if we see, we know that slope 1 is less than slope 2. So pressure 1 should be greater than pressure 2 since it is inversely proportional. So fourth option is the correct answer. In this question, we need to find the percentage error in resistance of a wire whose percentage error of length and diameter is given. So resistance of a wire can be written as R equal to rho L by A, where rho is resistivity, L is length, A is area. So area of a wire can be written as pi r squared, where r is the radius. Now we know how to deal this. So if we have a physical quantity C, which can be measured in terms of A into B power n, something like this, then the relative error of C can be written as addition of these relative errors. So delta A by A plus n into delta B by B. So irrespective of this n value, we have to put plus only. Even if the n is negative, we have to put positive only. So this is what we are going to use here. So delta R by R, which is equal to, here this rho is constant, rho and pi are constant, only length and radius are going to change. And since radius can be written as d by 2, this 2 is a constant. So whatever error is having, whatever be the error of this diameter, the same error the radius will also take. I can write here delta L by L plus 2 into delta R by R. Yeah, so you should not put negative 2 here. So error is always additive. We will never subtract anything while finding the error. Okay, so it should be plus 2 only. Even though when you write this, it may become L into R power negative 2. So don't put this minus here. It should be always positive. So since we need percentage error, so let's put it in terms of percentages. So delta R by R percentage, which is equal to delta L by L. And this is 0.1 percentage plus 2 into delta R by R, which is similar to the diameter, 0.1 percentage. So we'll get 0.3 percentage. Second option is the correct answer. In a plane electromagnetic wave, electric field oscillates at a frequency of 5 into 10 power 10 Hertz. So frequency of the electric field is given 5 into 10 power 10 Hertz, and its amplitude is given, let it be E0, that is 50 volt per meter. We need to calculate the energy density. So energy density of an electromagnetic wave can be written as U equal to half epsilon naught E0 square. So let's substitute 1 by 2 epsilon naught 8.85 into 10 power negative 12 E0 squared is 50 squared. So if you calculate, you will get 1.106 into 10 power negative 8 joule per meter cube. So first option is the correct answer. Here there is no need of frequency. It has been given to confuse us. We need to find the dimension of b squared by a. So let's figure out the dimension of a and b separately. Since it is addition, like ax squared plus bt power 1 by 2 is equal to force, which means ax squared should be equal to the dimension of force. So the dimension of A is force by x squared. Force means mass into acceleration. Mass is m, acceleration is meter per second squared. So length t power negative 2. And this is x squared, which means L squared. So with this, I can write dimension of A, which is m L power negative 1 t power negative 2. In the same way, we can figure out um, the dimension of b squared also. So b t power 1 by 2 is equal to force. B equal to force t power 1 by 2. But in the question, we need to find b squared. So let me write b squared, which is force squared by time. We can write the dimension, like we can just copy paste the same thing with the square. So this will be m squared L squared t power negative 4 divided by time. So the dimension of b squared is going to be m squared L squared t power negative 5. So we have the dimension of b squared and a also. So we can figure out what is b squared by a. So m squared L squared t power negative 5 divided by m L power negative 1 t power negative 2. So we will get m L cube t power negative 3. Yeah, first option is the correct answer. Two charges are there and they are q and 3q, which are separated by r distance. Now the electric field from the charge q at a distance x is 0, which means somewhere here the electric field is 0 and we need to find the value of x. For this the electric field is becoming 0. Now they just mentioned x distance from q, so it can be on the right side as well as in the left side. So I put up in the right side. Why? Because if we see the electric field direction due to this small q, it is in this way, because both are positive, it is in this way. Whereas due to the 3q, it is towards left side. So that's why in between the charges, the electric field directions are opposite. So there is a chance that the net electric field is going to be 0. In other directions, it's in the same uh, direction, which means like if you find the electric field here, both the electric field directions are towards right. Similarly, if you find the electric field in this region, both are towards left. So it cannot be 0. Only in between the charges, it will be 0. So that's why I have taken the right side of Q. So yeah, let me just redraw it. This is Q, x distance at this point electric field is 0 and we have 3Q and the overall distance is R. So which means this distance will be R minus X. Now if you have a charge Q at a distance R, the electric field can be written as E equal to KQ by R square. So we'll do the same thing. Since electric field magnitude is 0, which means electric field due to Q and 3Q should be equal to 0. Their magnitude should be same since the direction are opposite. So let me write KQ by X square, which is equal to K3Q by R minus X square. So KQ can be cancelled. So then we can rearrange this. Let me just write 1 by X squared equal to 3 by R minus X whole square. Now 3x squared equal to R minus X squared. Let's take a root. So root 3x equal to R minus X. Let's bring X one side. Root 3x plus X equal to R. So X will be R by 1 plus root 3. Just take the X common and then divide it. We'll get this one. So the value of X is R by 1 plus root 3. And this is an interesting question. There are two blocks which are placed on an inclined plane and the plane is having a rough surface whose coefficient of friction is given. So here mu is 0.25 and the mass is given, capital M is given, that is 10 kg. Small m we need to find, and the capital N is moving downward with an acceleration that is 2 meter per second square. So let's see what are the forces are acting on the capital M. It's a kind of known problem. Like when we have a inclined plane of angle theta, we keep a mass m here, then certain forces will act on it. One is the gravitational force, which is directly downward, mg, and the normal force, which is kind of perpendicular to that plane. If we take the component of this mg, then in this way, mg sine theta will act, and opposite to normal force, mg cos theta will act. So here, the normal force is going to be mg cos theta. So these are kind of initial things which we need to know. So the same thing I'm going to apply here. For this capital M, if we see uh, capital Mg will act downward. Not capital Mg, it's Mg sine 53. Will act in this way. Since it is connected with the rho, So the tension will act, since the mass is moving downward, so the frictional force will act opposite direction, that is upward. Let it be F1. So if we write the equation for this capital M, Newton's second law for capital M, then we have mg sine 53 degree minus tension minus frictional force 1, which is equal to capital M times A. Since here sine 53 is there, so this is a kind of special triangle. If we have a triangle, right angle triangle, whose sides are like 3, 4, and 5, the angles are going to be 37 and 53. So this will be 53. This is going to be 37 degree. So with this, we can write all the sine cos thetas. So let me just write it because we will need it. So sine 53 is equal to opposite by hypotenuse 4 by 5. Cos 53 is equal to 3 by 5. Sine 37 equal to 3 by 5. And cos 37 equal to 4 by 5. Just based on this triangle, we can write it. So yeah, this you should remember because some problem they will give in this special case. Okay, so we can figure out tension if we substitute rest of the things. So I'll keep tension one side, rest of the things other side. Mg sine 53 minus F. Okay, F also we can expand it. So mu times N. Frictional force can be written as mu times N. Normal force. Normal force in this case it is mg cos 53. Cos 53 degree and minus m times a. So let's substitute everything. M is 10, G is 10, sine 53, 4 by 5, minus mu is 0.25, M is 10, G is 10, cos 53, 3 by 5, minus M is 10, A is 2. So if we divide, we'll get 80, and here 260, 15, and this is 20. So we'll get 45 Newton. So tension we figure out that is 45 Newton. Fine. Now we need to figure out the small m. For that again we'll put this one. This is going to be mg sine 37 degree and tension is in this way, and the block is going to move upward because capital M is moving downward, so small m should move upward, and frictional force will act in the direction which is opposite to the direction of movement. So F2 will act in this way. We'll write a equation for small m also. I'll use other color for small m. So tension is acting upward. Mg sine 37 is downward minus frictional force is downward, which is equal to m times a. Yeah, tension and two forces are downward and acceleration is tension direction. So this is how it will look like. And we'll substitute the things. This is 45 minus mg sine 37 minus, again mu times n we will write. Here n is normal force mg cos 37 degree equal to ma. So let's bring the mass terms into one side. So we will have 45 equal to mg sine 37 it's not minus, it's plus mu mg cos 37 plus ma. So we'll take m outside and remaining things g sine 37 plus mu g cos 37. Sorry. plus A, which is equal to 45. So 45 equal to m into G sine 37. How much? 3 by 5. Mu is 0.25 into 10 cos 37. 4 by 5. Plus acceleration is 2. So m into this is 6 plus 2 8, yeah, 2 plus 2, which is equal to 10m. 45 Newton equal to 10m, which means the mass is going to be 45 by 10, which is 4.5 kg. So the mass of the small one is 45 kg. A coil is placed in an external magnetic field that is perpendicular to the surface of the coil. The magnetic field is perpendicular to the surface of the coil. Magnetic field is changing from 5000 Tesla to 3000 Tesla in 2 seconds. So I can write the change in magnetic field is 2000 Tesla, and the time it takes, change in time, is 2 seconds. Due to this, there is an induced EMF that is 22 volt. Diameter of the coil is given 0.01 meter. From this, sorry, 0.02 meters. From this, we can find the radius, that is 0.01 meter. So we need to find the number of turns in the coil. The induced EMF can be written as del phi by del t, rate of change of magnetic flux. This is due to one turn. If there are n number of turns, then it will become n times del phi by del t. So phi is a magnetic flux that can be written as B into A. So this will become n into del BA by dt. So since we want n only, I can rewrite this. N can be written as E delta T by delta B into A. So E delta T by delta B. Here area of the coil is pi r square. So we'll substitute everything. Induced EMF 22 volt, change in time 2, and change in magnetic field 2000, pi is 22 by 7, r square 0.01 square. Okay, so 22 will get cancelled, here 2 will get cancelled, and we left with 7 by 0.1, so which is equal to 70. So the number of turns in this case is 70. In this question, fundamental frequency of closed organ pipe is equal to first overtone of open organ pipe. So let's draw the closed organ pipe and open organ pipe first. This is closed organ pipe. One end should be closed. In open organ pipe, both the ends are open. So open organ pipe. Fundamental frequency. Let's see how it looks in closed organ pipe. So the standing wave pattern will look something like this. Okay, this is an antinode and this is a node. So the distance between antinode and node is lambda by 4. Now let's consider this length is L1. Length of this closed organ pipe is L1. So we can say lambda by 4 equal to L1, or L1 equal to, sorry, lambda equal to 4L1. Let's consider this is lambda 1. Now first overtone of open organ pipe. For fundamental frequency, like there will be only one node in the middle. For closed, uh, sorry, for open organ pipe, for the first overtone, there should be two nodes. So the pattern will look something like this, the standing wave pattern. Yeah. So here the distance between one antinode and node is lambda by 4. Here distance between two nodes are lambda by 2. Again, this one is lambda by 4. Let's consider the length is L2. So we can say here the overall length can be represented as lambda. If you add all of them, lambda by 4 plus lambda by 2 plus lambda by 4, it is going to be lambda, or let it be lambda 2. Now we know velocity can be written as wavelength times frequency. Now frequency equal to velocity by wavelength. So we'll write here frequency equal to velocity by wavelength. In this case, it is velocity by 4L1. So here, let's consider the frequency is F2 for this particular case, first overthrow, and this is velocity by wavelength or lambda 2. Here, L2. In the question, it is given that both the frequencies are same, which means this F1 and F2 are equal. F1 is equal to F2. V by not lambda 1, we can write in terms of length. 4L1, which is equal to V by L2. So from this, we can say 4L1 equal to L2 and L1 equal to L2 by 4. L2 is the length of open organ pipe, which is 60 centimeter. So since we want L1, which is L2 by 4, so 60 by 4, and it is 15 centimeter. So length of the closed organ pipe is 15 centimeter. A small steel ball is dropped into a cylinder which contains glycerin. So it looks like this. Okay, this is the ball. Now we need to find the velocity time graph of this ball. Now let's figure out the free body diagram of the ball. Let's consider the mass of the ball is m. Gravitational force will act, and as it travels inside the glycerin is going to exert a force, resistive force, which is going to oppose the motion, and that will act opposite to the gravity direction. And generally, this resistive force is due to viscosity, and if you see, it is going to depends on the velocity, viscous force. So it is going to depends on the speed of the ball. As the speed increases, the resistive force will also increase. At a particular speed, the resistive force is going to be equal to mg, the gravitational force. So the net force on the object is going to become zero, and after that the ball is going to move with a constant velocity, which is known as terminal velocity. So that's the idea behind this. Also, we can solve this problem based on um, differential equation as well. As we know that this resistive force is directly proportional to velocity, we can just write a equation and then solve it. But let's not do it that way. With the idea of terminal velocity, we'll just try to figure out which option is the best one. So you can look at the third option. Here you see the velocity is linearly increasing. So this is possible only if there is a constant forward acceleration. But in this case, we know that it's not possible, right? Because as the velocity increases, the resistive force will also increase, which doesn't uh, give constant acceleration. So the third one is not correct. And look at the fourth one. Initially, the velocity is non-zero, but in the question they have mentioned the ball is dropped. Dropped means initial velocity should be zero. So the fourth one is also not correct. And the first one, you can see that initially the velocity is increasing, then it is suddenly started decreasing. But this is also not possible because, as we discussed, it has to attain terminal velocity. So here, once it attains terminal velocity, it will just keep on going that particular value. So here, like it is decreasing, which will not happen. So this is also not possible. Only thing which is possible is second one. So if you extend this, it will just go in this way. which is the terminal velocity. So there is a disk. Let's consider this is the disk, and from this disk, the coin is placed at r distance from the center. So this is a top view, and this is our coin. So the disk is rotating with the angular speed or angular velocity omega. Now there is a friction between the coin and the disk. Coefficient of friction is mu. We need to find what is the maximum angular velocity so that the coin is not slipping. So this is a top view. Let's see the side view. So you can think that the disk is into the screen and this is our coin. So let's see what are the forces are acting on our coin. If this is our coin, and let's consider the mass of the coin is m. Gravitational force will act. So I'm talking about like this case. So in this case, the gravitational force will act downward, and the normal force will act upward, and centrifugal force will act outward. Frictional force will act in this direction. Since the coin is going to be at rest with respect to the disk, so we can equate the forces. Normal force should be equal to mg. The frictional force should be equal to centrifugal force. So here frictional force we can write it as mu into n, and centrifugal force mv squared by r. Here b is equal to r omega. So let's substitute the normal force mg, and this is m r omega squared by r. So m will get cancelled. Mu g equal to r omega squared. From this, omega equal to root of mu g by r. Third one is the correct answer. There are two conductors. They are having same resistance at 0 degrees Celsius. So at 0 degrees Celsius, two resistance R1 is equal to R2. Let's consider it as R. Now we need to find the temperature coefficients of them when they are connected in series and parallel. So their individual temperature coefficient is given, that is alpha 1 and alpha 2. So first of all, we should know how this resistance is going to change with respect to temperature. So resistance at a temperature T equal to resistance at 0 degrees Celsius into 1 plus alpha into delta T. So this delta T is change in temperature. So initially, since it is a reference point is 0, so this should be subtracted from 0 degrees Celsius. Fine. So we'll do for series. When two resistors are connected in series, the equivalent resistance is R1 plus R2. So at 0 degrees Celsius, what will happen to this R equivalent? It is R plus R, which is 2R. So let's use this particular equation and figure out the equivalent resistance at temperature T. R equivalent at T equal to R1T plus R2T. So this will be 2R, because at 0 degrees Celsius the equivalent resistance is 2R. So 2R into 1 plus alpha equivalent into delta T equal to R into 1 plus alpha 1 delta T plus R into 1 plus alpha 2 delta T. So the R can be cancelled on both the side. And let's rearrange this. 2 plus 2 into alpha equivalent delta T, which is equal to 2 plus alpha 1 alpha 2 into delta T. So 2 will get cancelled and we'll get alpha equivalent equal to alpha 1 plus alpha 2 by 2. So this is for series. Now let's do the same thing for parallel. So in parallel, the equivalent resistance, we have to take the reciprocal and then add them. So at 0 degrees Celsius, this R equivalent is going to be 1 by r plus 1 by r, which is equal to 2 by r. So the r equivalent is going to be r by 2. Now let's write the same equation in parallel form. So it is going to be r by 2, 1 plus alpha equivalent into delta t, which is equal to 1 by r into 1 plus alpha 1 delta t plus 1 by r into 1 plus alpha 2 delta t, 1 plus alpha 2 delta t. So the r can be cancelled and we can simplify this one. So this will become 2 by 1 plus alpha equivalent delta t, which is equal to, let's take the LCM and do things. This will become 1 plus alpha 1 delta t into 1 plus alpha 2 delta t, and here we'll get 1 plus alpha 2 delta t plus 1 plus alpha 1 delta t. Now we'll cross multiply. So 2 into, I'm going to bring this term here and this term here. Also we'll multiply this. So 1 plus alpha 1, no, alpha 2 delta t plus alpha 1 delta t plus alpha 1 alpha 2 delta t square, which is equal to 1 plus alpha equivalent delta t. Here I can simplify the numerator, 2 into alpha 1 plus alpha 2 delta t. So again, let's simplify this one. This is 2 into 1 plus alpha 1 alpha 2 delta t, and we can just neglect this t square. It's not equal to 0, but we can just neglect it because it's very small compared with delta t. And similarly, we'll find here also. So the first term will come as it is, 2 plus alpha 1 alpha 2 delta t plus 2 alpha equivalent delta t plus alpha equivalent alpha 1 alpha 2 delta t square. Again, we can neglect this one also. So we left with 2 into 1 plus alpha 1 alpha 2 delta t, which is equal to maybe I can expand this LHS. This is going to be 2 plus 2 into alpha 1 alpha 2 delta t, which is equal to 2 plus alpha 1 alpha 2 delta t plus 2 alpha equivalent delta t. So the 2 can be cancelled and we can subtract this alpha 1 alpha 2 delta t. So alpha 1 plus alpha 2 into delta t, which is equal to 2 into alpha equivalent delta t. The delta t will get cancelled and alpha equivalent will become alpha 1 plus alpha 2 by 2. So this is for parallel. So if you look at in series also, we got the same expression. So irrespective of parallel or series, it is going to remain same. There is an artillery of mass m1 which fires a shell of mass m2 horizontally. We need to find the ratio of kinetic energies, both of them, right after firing. So in this case, the momentum is going to be conserved. So momentum of mass m1 is going to be equal to momentum of m2. And we know how to write kinetic energy, which is half mv squared in general, and momentum is m into v. So here v can be written as p by m. Let's substitute here, and the kinetic energy will become p squared by 2m. So the kinetic energy of first mass by kinetic energy of second mass, which is p squared by 2m1. Since momentum is same, no, so let it be p. So this is p squared by 2m, and here p squared by 2m2. M1, M2. Now, if you rearrange, you will get M2 by M1. So, yeah, second one is the correct answer. This question is based on photoelectric effect. So, there is a metal surface. Initially, it is illuminated with a wavelength lambda, and the stopping potential is 8 volt. Then it is illuminated with the wavelength 3 lambda. Now, the stopping potential is 2 volt, and we need to find the threshold wavelength lambda 0. So in photoelectric effect, we can use the photoelectric effect equation, which is based on conservation of energy. So incident energy of the photon will be utilized in two ways. One is to take the electron out of the metal surface, which is known as work function phi, and then the kinetic energy of that particular electron. So you can think that there is a metal, we are shining a light, which means we are giving some energy in terms of photons. Because of that, the electron is going to come out. To take the electron, we have to spend some energy, that is work function. Once the electron is coming out, then it will move with some kinetic energy. So overall, this is going to be the final kinetic energy or the final energy. So incident energy, which is energy of the photon, is equal to final energy, which is work function plus kinetic energy of the electron. Here, the kinetic energy of the electron can be equated to stopping potential E into V0. Okay, so the equation is getting changed. E equal to pi plus E into V0. V0 is the stopping potential. Now, let's rearrange this one. E into V0 can be written as E minus phi. So, this incident energy of a photon, we can write it as hc by lambda. Similarly, the work function, we can write it as hc by lambda 0. Lambda 0 is the cutoff wavelength. So let's write this equation for each case. For the first case, the incident energy is lambda and the stopping potential is, I think, 8 volt. Let me look. Yeah, 8 volt. So E into 8 volt equal to hc by lambda minus hc by lambda 0. So from, okay, let it be there. Let's write for the second case. In this case, it has 2 volt. E into 2 volt equal to hc by 3 lambda because incident wavelength is 3 lambda. And the work function is going to remain constant because it depends on the material. So the metal is same, the work function should be same. Since we need to find the lambda 0, and we'll try to rearrange this equation and figure out. So from this, I just want to write electron volt on the left side. It is going to be 1 by 8 into hc by lambda minus hc by lambda 0. Let it be equation 1. And similarly, I want to write electron volt here, which will be 1 by 2 into hc by 3 lambda minus hc by lambda 0. So if you look at the two equations, left side is same, which means the right side should also be same. So 1 equal to 2. Let me write here 1 by 8 into hc by lambda minus hc by lambda 0, which is equal to 1 by 2 into hc by 3 lambda minus hc by lambda 0. So this will become 4. This we can cancel, and this hc terms we can cancel. So we left with 1 by 4 lambda minus 1 by 4 lambda 0, which is equal to 1 by 3 lambda minus 1 by lambda 0. Let's bring lambda 0 terms one side and lambda terms another side. We will get 1 by lambda 0 minus 1 by 4 lambda 0 equal to 1 by 3 lambda minus 1 by 4 lambda, and this is going to be 3 by 4 lambda 0 equal to, I think this is 12 lambda 1. From this we can write lambda 0, which is equal to 9 lambda. So here the cutoff wavelength or threshold wavelength is 9 lambda. An electron is moving in a uniform magnetic field. Magnetic field is given and the velocity of the electron is given. Force acting on the electron is given, and this should be k cap. And we need to find the magnetic field magnitude B0 we need to find. So generally when a charged particle moves in a magnetic field, then it will experience a force which we can write it as Q into V cross B. So in our case, Q equal to E, charge of electron. So let's figure out V cross B. V cross B is I, J, K. First we need to write B, 3, 5, 0, then B. It is B0, 2B0 and 0. So I and J terms will get cancelled. Only we will have K. So K into 6B0 minus 5B0, which is equal to B0. So the force or the magnitude of force, we can write it as it will become E into B0. And the force what they have given in the question is 5E, which is equal to E into B0. So from this we can write B0 equal to 5.
So there is a parallel plate capacitor. Let's consider this is a parallel plate capacitor. Distance between the plates are 5 mm and it is connected to a battery. So some amount of charge is stored in it and they are adding some dielectric between the plates. So let's consider this is the dielectric between the plates they are adding, and this thickness is 2 mm and the dielectric constant is K. We need to find this dielectric constant, and one more thing is given, that is how the charge is changing. So initially charge is Q and the final charge becomes 25% more than the initial charge, which means Q plus 25% of Q, which is 1.25 Q. This is the final charge. So initial charge is Q and final charge is 1.25 Q. So let's do this problem by considering initial case and final case. So this is initial and this one is final. Initially, how do we write the capacitance? It is going to be epsilon naught A by D we will write. Instead of D, I am going to write 5. So don't ask do we need to write in meter and all, because here we will be comparing the capacitance. So whatever you need to write, that will get cancelled. If you write even in millimeter, that is going to get cancelled. You need not to write this in meters. So this is the initial capacitance and the initial voltage is V and initial charge is Q. And finally, let me draw that figure one more time. So we have the plates and this dielectric, this is 2 millimeter. So this is going to be 3 millimeter. Now this circuit this setup we can convert into a circuit by considering that there are two capacitors, C1 and C2. the top plate and the top surface of the dielectric will act like a capacitor, and the top surface and bottom plate will act like another capacitor. So that's what I have written. I have drawn C1 and C2. Now they are in series, and if we figure out this, then we will get the final capacitance. So if they are in series, we have to take the reciprocal and add. So 1 by Cf equal to 1 by C1 plus 1 by C2. That is, let's write the expressions. 1 by Cf is equal to 1 by C1. C1 in this case it is epsilon naught A by 3. There is no dielectric medium, so this is fine. And C2 is K times epsilon naught A by 2 because there is a dielectric. And this dielectric constant we are considered as K. Now, if we simplify this, we will get, so maybe I can just take whatever things are common. 1 by epsilon naught A I can take. We left with 3K plus 2 by K. So the final capacitance is going to be epsilon naught A divided by 3K, the final capacitance. And final charge, as we discussed, 1.25 times of initial charge, which is Q. And final potential difference is going to be V only, because uh, the battery is still in connection. As long as the battery is in connection with the capacitor, the potential is going to be same. So these are the stuff we have. Initial parameters, final parameters we have. So let's compare these two and get the answer. Final charge equal to 1.25 times of initial charge. So how do you write charge? Charge can be written as C into V, capacitance into voltage. So I'll write here, which is equal to initial capacitance into initial voltage. And this one is epsilon naught A K divided by 3K plus 2 into V, which is equal to epsilon naught A by 5V. So this V, epsilon naught A, we can cancel. We left with K by 3K. Oh, sorry, I made a mistake. This 1.25 I left it. Should be 1.25. Yeah, by 5. Because like the final charge is 1.25 times of initial charge. So this is final charge. This is initial charge. I have to multiply 1.25. Okay, now we'll do this 5K equal to 1.25 into 3K plus 2. We rearrange, then 5K minus 3.75K equal to 2.5. 1.25K equal to 2.5. So K equal to 2. So the dielectric constant of the sheet is K, or K which is equal to 2. Yeah, here the key idea is we are equating the charges by finding the capacitance.
In this question, we need to figure out the equivalent resistance. So resistor network is given. If you look at this carefully, you will know that this 6 ohm is short circuited because both the sides are connected to a same point. Wire is there. So which means this 6 ohm is not going to play any role. We can simply remove it and redraw this circuit. So let me redraw this. We will have 2 ohm, then again 2 ohm, this is 2 ohm, here 3, and this is also 3. This is 2, this is 2. Yeah. So if you look at this 2 ohms, they are in parallel. And if they are in parallel, their effective resistance is going to become 1. So instead of this two resistors which are in parallel, I can replace them with 1 ohm. Let me do that. So this is 1 ohm, which is the effective resistance between this two ohm resistors. Then here we have 2 ohm. We have 3 ohm here. Then another 3 ohm here. This is the point A and B. Now if you look at 1 ohm and 2 ohm, they are in series. So if they are in series, we can simply add them. So it will become 3 ohm, here 3 ohm, again here 3 ohm. So three resistors are in parallel and all are same. You can use the expression 1 by R total equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if you figure out, you will get the total resistance is to be 1 ohm. And the other way is like if the equal resistance, same resistors are in parallel, then their effective resistance is going to become, in case if two are there, then it is going to become half. Or if n number of resistors are there in parallel and all are same, then the total resistance is going to become R by N. So here, since three resistors are there and each of resistance 3, it is going to become 3 by 3, which is 1 ohm. So there is a solid circular disc and its mass is 50 kg. It is rolling on a horizontal floor. And center of mass is moving with the speed 0.4 meter per second. We need to find the work done to stop it, absolute work value to stop it. So first we'll write the given parameters. Mass is given and speed is given. We need to find the work done. Mass is 50 kg, speed is 0.4 meter per second. So work done we can figure out using work energy theorem, that is change in kinetic energy. So change in kinetic energy means final kinetic energy minus initial kinetic energy. As it is stopped, so final kinetic energy is going to be 0 and the initial kinetic energy, it will have two components, because like if you see how the disc is rolling, you can think of a cycle tire. While the cycle is moving, if you look at the cycle tire will roll as well as it will move forward. Same thing is going to happen here. Also, it is given that rolling motion. So whenever rolling motion comes, this expression is valid. V equal to R omega, where V is the speed of center of mass, like with which speed it is moving. R is the radius, omega is the angular speed. Okay, so this should be satisfied. Then only it can roll. Otherwise, it will be slipping or sliding. So here the initial kinetic energy is kinetic energy due to translational motion plus kinetic energy due to rotational motion. Since they asked about absolute value, which means they don't care about the sign, they just want the value. So we need not to worry about this negative sign and all. We'll just write it. Translational kinetic energy is half mv squared. Rotational kinetic energy is half I omega squared, where I is the moment of inertia. And for the disk, a solid disk, moment of inertia about an axis passing through the center of mass is given by 1 by 2 m capital R square. M is mass, because it should be small m, because I have used small m already here for the disk mass. So let's write 1 by 2 mb squared plus 1 by 2 mr squared. Oh, another one. Yeah, mr squared by 2. This is the I and this is omega squared. So now since it is rolling, so r squared into omega squared should be equal to v squared. 1 by 2 mv squared plus 1 by 2 mv squared by 2. This is the absolute work done. And we can simplify this. Let's take mv squared by 2 outside. We'll get 3 by 2. And we'll substitute m is 50 kg, v is 0.4 into 0.4. This is 3 divided by 4. So this will be 0.1. So 1.26 joules. So the absolute work done is going to be W, which is 6 joules. This is a really good question. So try to pause the video and read the question. Try to visualize it. Once you are able to visualize, then things are easy. So let me explain the question with a figure. So in the question, it is given that there is a ball. This is the ball which is falling from the height h. So let's consider this height is h, capital H. And there is an incline. It is hitting the incline at the height small h. So here it is hitting, and this height is small h. So whenever they are telling height, you have to measure from the ground level, not from the top. So it is coming, it is hitting here, then it is become horizontal. Its velocity becomes completely horizontal. Okay, then if you see its motion, it is going to be projectile motion kind of thing. It will hit the ground. So overall, from where it is dropped and where it is hitting the ground, it is taking time t. So in order to maximize this time to reach this ground, what is the value of this capital H by small h? That's what we need to find. So in this process, there are two times involved. First time is like this one, like it is dropped and it is going to hit the incline. It will take certain time, let it be t1. Then next one is after hitting the incline, it is becoming horizontal and it is going to reach the ground. For that, the time is t2. So this is the total time. So let me explain this with a simple idea. Consider this is a ball and it is dropped from the height x. It is reaching the ground. How to find the time taken for this one? We can use equation of motion, which is s equal to ut plus of at squared. So since it is dropped, so the initial velocity is 0. Now the time is going to become, since s equal to x, it will become 2x by, sorry, yeah, it's correct, 2x by g. The same idea I'm going to use it here. This distance is going to be capital H minus h, and this distance is h only. And here also we can use the projectile motion idea, like initial vertical velocity is going to be 0 in this case also. So if I write this, t1 will be 2 h minus h by g plus 2 small h by g. This is the total time. Now we need to maximize this time. So this time depends on only one thing, or only one variable, that is this small h, right? So we can differentiate this time with small h and equate it to 0. When we do this, we can get the ratio. So let's differentiate. dt by dh. I think it's better to take some components out which are common. This 2 by g is kind of common. Then we left with root of h minus h, or h minus h power 1 by 2 plus h power 1 by 2. So we get root of 2 by g. This will become negative 1. Okay, can write in this way. 1 by 2 into h minus h, negative 1 by 2 into negative 1. So I have used the chain rule, and plus 1 by 2 h power negative 1 by 2, and this should be equal to 0. Now we can take this 1 by 2 common, and when this root 2 by g goes that side, it will become 0. So it will become h minus small h power 1 by 2 negative plus h power negative 1 by 2, which is equal to 0. So we can write h minus h equal to h. When you rearrange and square it, then h by h will become 2. So here the ratio is going to be 2. Two waves are there. Their intensities are in the ratio of 1:9. So let's consider the intensities of each waves as Ix and Iy. So Ix by Iy equal to 1 by 9. So we can write Iy equal to 9 times Ix. Now, in the first case, those two waves are in incoherent mode. They are incoherent and they are meeting at a particular point. At that particular point, the intensity is given as I1. So when they are incoherent, which means they are made up of two different wavelengths. Their frequency is different. So in that case, there is no interference possible. Those two waves are not going to interfere with each other, which means the resultant intensity is just the addition of two intensities, Ix plus Iy. So this is Ix plus 9 times Ix, so 10 times Ix. This is our I1. And in the second case, they are coherent. Coherent in the sense they will have same wavelength, which means they can interfere. So when they interfere, the intensity we can write in this way: Ix plus Iy plus 2 into root of Ix Iy cos phi, where phi is the phase difference between them. So in this case, phi is 60 degree, also cos 60 degree equal to 1 by 2. So let's substitute Ix. Iy is 9Ix plus 2 root of Ix into 9Ix. This is 1 by 2. So this 2 and 2 will get cancelled, and we left with Ix plus 9Ix plus 3Ix. So this will become 9Ix squared. When you take a square root, you will get plus 3Ix. So this is becoming 13Ix, which is our I2. So we want I1 by I2, which is 10 by X, I1 by I2, 10 by X. So in our case, we got I1 equal to 10Ix and I2 equal to 13Ix. This Ix will get cancelled. We left with 10 by 13. So when we compare with this one, the X is going to be 13. This is 13. This question is based on mutual inductance. There are two square loops of different side length, and they are placed in a same plane and their centers are coinciding. We just need to find the mutual inductance of this system. So let's draw the figure. Consider these are the two square loops. The bigger one is having side length capital L, smaller one is having side length small l. Now let's assume that current is going on the bigger one, and due to this current there will be some magnetic field linked with this smaller loop. Because of that, there will be a magnetic flux which we need to find. Uh, so before that, let's see how to calculate mutual inductance for two coils, which is quite common. So let it be coil 1, coil 2. So coil 1 is having some current I. Due to this current, there will be a magnetic field. Because of that magnetic field, there will be a magnetic flux in the second coil. So the mutual inductance we define by the magnetic flux linked with coil 2 divided by the current flowing in the coil 1, I1, into number of turns in the coil 2. So this is how we define. The way around is also possible. So in the same way, if you want to write the magnetic flux, or based on that, if you want to write the mutual inductance, it is going to be the magnetic flux due to smaller one divided by the current. So here our aim is to find this magnetic flux linked with this smaller loop. How do you write magnetic flux? It is magnetic field times area. So which one is giving magnetic field? The bigger one. So let's take only one side of it. Current I is going, and due to this, let's figure out the magnetic field at the center, which is L by 2 distance from this side. The side length is L. So there is a standard expression for magnetic field due to this wire. If this is theta 1, this is theta 2, then magnetic field is given by mu naught I by 4 pi r into sine theta 1 plus sine theta 2. So in our case, this theta are equal to 45 degree. So theta 1, which is equal to theta 2, which is equal to 45 degree. And r is equal to L by 2. Since it is a square, so the things are little simpler. And this is the magnetic field due to only one side. If we find due to the magnetic field due to the entire square loop, it is going to be 4 times. So the total magnetic field is 4 times mu naught I by 4 pi L by 2 sine 45 degree plus sine 45 degree. So this is 4 into mu naught. Mu naught is 4 pi into I divided by 4 pi L by 2. Sine 45 is 1 by root 2. So this is 2 into 1 by root 2. This is the magnetic field, total magnetic field. Now we want the magnetic flux. Magnetic flux is magnetic field times area of the smaller loop. So we'll cancel some terms with this 2. No, will not get cancelled. Yeah. So we left with 4 pi into 4 by root 2 L into L squared. L squared is the area of the smaller loop. In the question it is given L squared equal to capital L. So we'll substitute that value also. So 4I into 4 by root 2 L into L. This L will get cancelled. This we can simplify to root 2. So we are getting 8 root 2 I. Okay, this is the magnetic flux due to the smaller one. We want mutual inductance, which means magnetic flux due to smaller one by current. So we get 8 root 2. Oh, sorry, I forgot to put 10 power negative 7 for mu naught. Mu naught equal to 4 pi into 10 power negative 7. So I forgot to put up 10 power negative 7, 10 power negative 7. This is also 10 power negative 7. Yeah, so if we see, it is written root x. So which means we want to write everything inside the root. It is 8. If it take into the root, it is going to be 64. 64 into 2, 128 into 10 power negative 7. So the value of x is 128. Yeah, it is 128. This question is based on bulk modulus. There is a rubber ball which is kept a certain depth below the surface of sea, due to which the volume is decreased by 0.02 percentage. So we need to find that depth, how much depth the ball has been kept. So we should know two things. One is how to write a bulk modulus. So bulk modulus is basically stress by strain. In this case, we can write a change in pressure divided by change in volume by volume. So stress is basically force per area, which is the pressure. Strain is change in dimension by original dimension. So change in volume by initial volume. And this pressure we should know. So let's consider this is the surface level, like sea level, and I mean sea surface. Sea surface, initially ball is outside, so the pressure on the ball is atmospheric pressure, PA. And when we keep the ball under the sea at certain depth, say for H, then here the total pressure is going to be atmospheric pressure plus rho GH. So now the change in pressure becomes rho GH because this has PA, atmospheric pressure, will get cancelled. So let me write change in pressure equal to beta into delta V by V. So change in pressure is rho GH. This is beta. Change in dimension, that is 0.02 by 100 V divided by V. So this particular thing, we got it from this information, 0.02 percentage. We want H. So H is equal to beta rho G. Here we can cancel out this V and V. We get 0.02 by 100. So let's substitute everything. All the informations are given. Beta is 9 into 10 power 8. And this we can write it as 2 into 10 power 1, 2, negative 2. Rho is 10 power 3, G is 10, and 100 is 10 power 2. So we get 18 meters. So the depth should be 18 meter.
A particle is exhibiting simple harmonic motion with amplitude A, and its speed is increased to 3 times. Displacement is 2a by 3. We need to find the new amplitude of motion. So let's do it in a two cases. Let's consider the initial case. We'll figure out the speed at the given displacement. Then we'll do the final case where the speed is 3 times of initial. So let me write initial first. This is initial. Initially amplitude is A, and the speed is V. Let's consider it as V, and the displacement is 2a by 3. This is final case. Finally, let's consider amplitude is A dash, speed is V dash, which is 3v, and the displacement still remains same, 2a by 3. So in this problem, the information is given in terms of speed and displacement. So we should know the relation between speed and displacement. That is v equal to omega into root of a squared minus x squared. In this expression, the x is the displacement. So let's do for the initial case. V equal to omega into root of a squared minus instead of x, 2a by 3 whole square. So v equal to omega into root of a squared minus 4a squared by 9. So this will become omega into uh, root 5 a by 3. So if you take LCM and subtract, it will become root 5 a by 3. So this is the initial speed. Let's do the final case. V dash, which is equal to omega into root of a dash squared minus x. So this is omega a dash squared minus, instead of x, it is 2a by 3 whole square. And this v dash, I can write it as 3 times. And this V we know, so let's substitute 3 times V. V is omega root 5 A by 3. Over here we figure out the V. I substituted, which is equal to omega into root of A dash squared minus 4A squared by 9. So this 3 will get cancelled. Omega will get cancelled. We left with 5A equal to root of 9A squared, sorry, 9A dash squared minus 4A squared by, let's square both the side. We get 5A squared, which is equal to 9A dash squared minus 4A squared by 9. So let's rearrange 45 A squared equal to 9 A dash squared minus 4A squared. So 9 A dash squared equal to 49 A squared. So A dash equal to 49 by 9 A squared whole root. This will become 7 by 3 A. So we are getting A dash equal to 7 by 3 A. Our new amplitude is 7 by 3 A. So here n should be 7.
In a particular reaction, mass defect is given and we need to figure out amount of energy liberated. So